Share screen. Good afternoon, everyone.
Good afternoon, sir.
Okay. Diploma students, those who are joined, already you studied with DC missions. DC missions already చదివింటారు. In the last online classes in the previous months, we discussed about DC generator construction and what are the construction, what is the construction of DC generator, how DC generator works, what is the principle of a DC generator, Faraday's laws of electromagnetic induction, and the EMF equation of a DC generator is EMF equation of a DC generator is pi Zn P by 60A. The EMF equation of DC generator, we already discussed that pi Zn P by 60A. Based on that, some problems we have to do. The problems regarding EMF generated equations pi Zn P by 60A. We know that EMF generated is Eg equal to pi Zn P by 60A. Okay. Okay, in the DC mission, pi Zn P by 60A, based on that, some problems we will discuss later. Now, what is the construction of DC generator? Normally, are you watching the screen or not? In DC mission, what are the parts? Actually, my armature is rotating and the main field flux is constant, that is given by DC supply. In DC mission, two kinds of magnetic fluxes are present. One is armature flux, another one is main flux. Armature flux is generated due to current flow in armature conductors. Whenever current flows through armature conductors in DC generator, that will be collected by brushes. That is the armature flux will be generated, because whenever current flows through DC generator, armature also current, there are two parts in the DC generator in the construction point of view. One is generator, one is stator, another one is rotor. In stator, what are the parts? Armature comes under stator or rotor? I can answer anyone. Armature comes under stator or rotor. DC generator or DC machine, anyone, both are same constructionally. DC generator or motor, whatever be that, it is same constructionally. Armature comes under rotor, whereas magnetic flux, main field flux, field winding will be in stator. The poles are rotor, poles are inside. One person is waiting again. Okay. Poles are inside. Between the poles, we are placing interpoles. So many constructions point of view, we discussed the dummy coils in armature winding, lap winding, wave winding. There are two types of winding present in DC missions. One is lap, another one is wave winding. Lap winding, how the nature, and the wave winding, what is the nature, what are the equations related to back pitch, front pitch, all we discussed in the previous classes. Now we go for the important topic, which is armature reaction. Armature reaction, it is, you know that what is if you take a medicine, there are some side effects that is called reactions. If you take one medicine, what happens? if the medicine is work properly, your fever, whatever be the disease, that will be nullified. Similarly, if there is a reaction in your body, say, or if you use another medicine, another type, some medicines are there, some reactions will come. Similarly, armature also produces some current. Whenever current carrying conductor placed in a magnetic field, a torque will be produced. Similarly, whenever a conductor is moved in a magnetic field, what happens? An EMF will be generated because armature conductors in DC machines are closed windings. You know that armature windings are closed windings in DC machine. Due to that, a current will be flow because of due to that a current will be flow in the armature of the DC machine. Hence, a flux will be produced. And two fluxes will be there in the DC machine or DC generator or machine, whatever it is. That flux is armature flux and main field flux. In the armature, these two fluxes interaction gives armature reaction. The effect of armature flux on the main field flux is called armature reaction. We have to remember what is meant by armature reaction. The armature reaction is the effect of armature flux on the main field flux. We have to remember what is the effect of armature flux on main field flux is called armature reaction. I already told you whenever a DC generator produces a voltage due to short conductors, a current will flow. That current produces a flux. That is called armature flux. Due to that armature flux, what is the effect of armature flux on the main field flux is called armature reaction. The effect of magnetic field set up by the armature current on the distribution of flux under the main poles of a DC generator is known as armature reaction. Main poles are there to produce main flux, whereas armature conductors produces armature flux. The effect of armature flux, which is affected, main field flux will be affected. Main flux will be affected. Main flux is the major cause to produce EMF, but that flux is opposed by the armature flux. That total process is called armature reaction. Once again, what is the definition of armature reaction is the effect of armature flux, armature fluxes on the main field fluxes is called armature reaction. Main field fluxes are produced by magnetic poles, whereas armature flux is produced by armature winding. The armature reaction produces two important reaction. What are the effects of armature reaction? Two important effects. Distortion of the main flux. One is effect is distortion effect that weakens the main flux. That means it is also known as demagnetization effect or weakens the main flux. Demagnetization effect causes weakens the main flux. And another one is cross magnetization effect. Okay, these are the two effects which are caused by armature reaction. It is very important to note that what are the effects of armature reaction. Simply, it demagnetizes or weakens the flux, main flux, and cross magnetizes the or distorts the main flux. Distortion effect creates cross magnetization, and demagnetization effect creates weakens the main flux. Weakens the main flux. Whenever flux is weakened, what happens? E is equal to pi z and p by 60a. Some persons are entering again. Pot spent. Okay. There are two effects I am telling you. One is demagnetization effect weakens the main flux. This is very important effect that is there in DC generator to D weakens the main flux means whenever flux is weakened, EZ is directly proportional to phi. You know that generated EMF is always proportional to magnetic flux phi, hence it reduces the generated voltage. It is the one of the effect. Another one is cross magnetization effect or cross magnetic effect. Distortion the main flux. It distorts the main flux. Okay, let us consider how to explain the armature reaction. What is GNA? What is MNA? GNA full form is geometrical neutral axis. MNA full form is magnetic neutral axis. What is meant by GNA? What is meant by MNA? The geometrical neutral axis is that it is the axis that bisects the angle between the two center of lines of the poles. Two poles మధ్యలో వెళ్ళేది GNA, geometrical neutral axis. It bisects the centerly and the middle of two magnetic poles. It flow. That is GNA. You can see in the diagram GNA and MNA both are in coincide nature when there is no load on DC generator. When there is no load on DC generator, when there is no load on the DC generator, the GNA and MNA both will be coincide each other. When there is a load, the GNA and MNA both not coincide each other because of the load. Because of the load means the magnetic flux will be distorted by the production of armature flux. That is GNA and MNA both are some angle. So this in the below diagram you can see this GNA and MNA are displaced by an angle theta. That angle also important. GNA MNA, that is in the figure 1, the starting of the figure, main field flux and armature flux, both GNA and MNA both are coincide because there is no load. When the DC generator is not connected to any type of load, suppose a lamp load or a lamp load is nothing but resistive load. When GNA and MNA both are coincide each other means there is no load. There is no load means there is no current in armature, hence armature flux is zero, hence G and MNA both are coincide in nature. The brushes are laying in the magnetic neutral axis. What is MNA? The magnetic neutral axis is the axis along which no EMF produced in the armature conductors. It is magnetic neutral axis when there is no EMF produced in the armature conductors because they move parallel to the lines of the flux. The magnitude and direction of MMF producing the main flux is represented by the vector OFM. Actually, a vector diagram is there. That vector diagram we'll discuss later class. Actually, consider there is no current in armature conductors and only field winding is supplied. Field winding means main field winding is supplied. When there is no current in armature conductors means there is no load connected to armature because this generator is not connected to any load to supply any load and only field winding is supplied. In this case, magnetic flux lines due to field poles are uniform and symmetrical. Polar axis means MNA and the magnetic neutral axis MNA coincide with the geometrical neutral axis GNA. This diagram is important. The GNA and MNA both are coincide in nature means there is no load. When there is a load, armature flux rotates. In this diagram, you can see armature flux rotates. At that moment, what happens? The GNA is simply split some angle, this angle. That is the effect of armature flux. The effect of armature flux is to split the MNA through by the GNA. From the GNA to MNA, the angle is theta. When the generator is loaded, current flows in the armature winding. The armature current produces armature flux. The armature current produces armature flux. This flux due to armature current alone with main poles unexcited. When unexcited, the main poles, according to Fleming's right-hand rule, the direction of current in the conductor lying conductor N pole downwards, N pole, north pole, you can see the conductor current is downwards. This is marked by cross mark or plus mark or cross mark it is. It is not plus, it is cross mark. The direction of current in the conductor lying under N pole, north pole is in downwards shown by cross mark, whereas current in conductor lying S pole is upward shown by the dotted line. The direction of lines of force can be found by clock screw rule. You know that the direction of armature current is downwards through the armature and parallel to the brush axis. The magnitude and direction of mmf producing the armature flux is represented by, and when some vectors we have to draw OFA actually. This is centrally it is O. FA will be rotation. Due to rotation, MNA OFA will be created. That is the axis which is perpendicular to air gap flux is known as MNA actually. This is the axis which is perpendicular to MNA. Now, phenomena of demagnetization and cross magnetization effect on some angle theta mechanical, theta electrical conversion, all this will be discussed in the next class actually. And one numerical problem will be discussed after that. Demagnetization effect and cross magnetization, number of conductors comes under demagnetization effect, ATD per pole and ATC per pole. Derivations are there. These derivations not in PPT form. Next class we will discuss the two derivations of ATC. Derivations discuss చేయాలంటే మనం ఆల్రెడీ డిరైవ్ చేసిన చేసాము. ఆ ఈక్వేషన్స్ ఎక్స్ప్లెయిన్ చేయాలి. What are the effects? What are the adverse effects of armature reactions? The armature reaction weakens the main flux, that is demagnetization effect. In case of generator, weakening of the main flux reduces the generated voltage. That is one of the effect. Definitely 2 marks questions will be come from armature reaction. What are the adverse effects of armature reaction? It weakens the main flux means when it demagnetization happens, it weakens the main flux. In case of generator, weakening of the main flux reduces the generated voltage. Armature, and second effect is armature reaction distorts the main flux, cross magnetization effect. Distortion will be happen when the flux is coming from north pole to south pole. It simply distorts means whenever air is came, the powder which is on the road or the dust which is on the road, whenever air came, whenever vehicle move, the dust will be distorts. Similarly, when armature flux enters, the main flux will be distorts. Hence the position of MNA gets shifted. MNA is perpendicular to flux lines of main flux. Actually, MNA is the magnetic neutral axis which is perpendicular to magnetic flux lines. That is called MNA. GNA is which is in between the two poles, the axis which is passing through between two adjacent poles, north pole and south poles. Brushes should be placed on MNA. It is very important to know that the brushes, where we have to place the brushes. The brushes should be placed on magnetic neutral axis, which is perpendicular to main field flux. Otherwise, it will lead to sparking at the surface of the brushes. What is meant by sparking? Why the sparking occurs in DC missions are due to commutation. So due to armature reaction, it is another effect is commutation. Some important points is in DC mission, the carbon brushes are always placed at the magnetic neutral axis. It is very important where the carbon brushes are placed. It is always placed at magnetic neutral axis. In no load condition, the magnetic neutral axis and GNA, both axes coincide with each other. When the machine is loaded, armature flux is directed along the interpole axis. This axis between magnetic poles, and it is triangular in wave shape. Some wave also we will see. This is the MMF flux variation in unloaded mission. Unloaded missions lo ela untundi. MMF, magnetomotive force, main field permeance, and practical flux density. Flux density, it is very important to gate also. It is very important to gate also. The flux wave, it is flux wave will practically, the flux wave will be in square shape actually, not exactly square wave. It is a disturbed square wave. Ideal flux density will be square wave exactly. But practical ideal is not practically. It is practically it is a not square shape. Some get important. These waveforms will be comes in the competitive examinations. MMF and flux distribution on the action of armature alone carrying current. It is the flux wave. Already I told you trapezoidal wave. Flux wave will be that is not exactly square shape. It is trapezoidal wave. It is trapezoidal wave. Okay, you can see here armature reaction effect. Commutating poles, compoles అంటారు దీంట్లో. Commutating poles are interpoles are known as also known as compoles. Interpoles another name is compoles. What is the purpose of compensating winding? To reduce the armature reaction effect, we are providing compensating winding, which is between two poles in armature. Sorry, compensating winding or interpoles and compoles both are same. In the diagram, what is the schematic diagram of DC generator, we drawn interpoles also. What is the purpose of interpoles? Okay, the two main effects of armature compensating winding current. What is the purpose of compensating winding? To reduces the armature reaction, we are using two compensating winding are provided at the pole faces. Pole faces lo compensating winding provide చేస్తారు. Compensating winding, it is also known compoles. These are interpoles. Interpoles are along with, but narrow poles are placed in the interpole axis. They have polarity of, they are simply dummy coils also there in case of armature winding. To balance the armature mechanically, we are placing dummy coils or armature winding. While designing armature winding, we place the dummy coils in the armature winding. And one diagram also how to draw lap winding, how to draw wave winding. All this will be offline classes. In the offline classes, we will draw practically in the blackboard on a number of slots based on that back pitch, front pitch, and number of slots provide చేసి మనం వైండింగ్ డ్రా చేస్తాం. ఆ వైండింగ్ అన్ని క్లాసెస్లో ఆఫ్లైన్ మండే నుంచి ఉంటాయి కదా, అప్పుడు మనం డిస్కస్ చేద్దాం. ఇక్కడ డీసీ మిషన్స్ వీ కాంట్ ఎక్స్ప్లెయిన్ డైరెక్ట్లీ by off online mode. We have to draw on the blackboard, then you can easily understand. Until you practice the wave winding, lap winding, any one winding will come in examination. Okay, next class, direct offline mode, we will attend, we will explain what is the armature winding numerical problems, and lap winding, wave winding, diagrams, how to draw. For diploma holders, already you drawn the lap winding, wave winding in engineering drawing or missions drawing, you drawn that lap winding, wave winding. Similarly, we have to draw on the white paper for examination purpose. If you practice, then only you can understand easily. Okay. Next class, we'll offline mode, and Monday we will start lap winding, wave winding diagrams, how to draw. Okay. Next class, we'll meet with armature windings, how to draw in the classrooms. Thank you. Or I understand that what is meant by armature reaction. The effect of armature flux on main flux is called armature reaction. Two effects. What are the effects? What are the GNA and MNA? How the GNA shifts MNA? All will be comes under armature reaction. And ATD per pole, that is armature reaction effect, demagnetizing ampere turns per pole, and numerical problems also there. Those will be discussed in next class. Okay, ma. Thank you.